Okay, let us continue with the determination of molarities of solutions. Bear in mind that molarity is the number of moles of a substance in 1,000 cubic centimeters of its solution, whereby 1,000 cubic centimeters is the same as 1 liter or 1 cubic decimeter. Now let us look at this example here of 19.6 grams of sulfuric acid in 200 cubic centimeters of solution, of its solution, given that hydrogen has a relative atomic mass of 1, sulfur with a relative atomic mass of 32, and oxygen with a relative atomic mass of 16. Let us look at how we can get the molarity of this solution. So we saw that we can use two different methods, and let us discuss those methods once again, one by one. Starting with the first method, that is by firstly converting this mass here into moles, and that will be the mass in 200 cubic centimeters of solution. Then later on, we shall convert that number of moles in the 200 cubic centimeters to the number of moles in 1,000 cubic centimeters. And that is what gives us what we call the molarity of this solution in our method number one. So let us firstly convert this mass into moles. So if we are converting mass into moles, what do we do? In this case, what we do is we have to firstly work out the molar mass of that very substance. So we are dealing with sulfuric acid. Let us get the molar mass of sulfuric acid using the chemical formula of sulfuric acid in this case. So we are starting with hydrogen. We shall add the relative atomic masses together. Hydrogen is 1 times 2 plus 32, that is for sulfur, 1 atom, plus oxygen, there are 4 atoms, that is the relative atomic mass of oxygen, 16 times the 4 atoms of oxygen. And if we add these ones here together, this one will be 2, this one will be 32, and this one will be 64. So 64 plus 32 gives us 96, plus 2 is 98 grams. That is the mass of 1 mole of sulfuric acid. So let us convert now this mass here into moles using the mass of 1 mole that we have got here. Remember, this is the mass of 1 mole, and we are looking for number of moles of sulfuric acid in the 19.6 grams. So we shall take what we are looking for to the right hand side. That is, we shall take moles to our right hand side, and we start from the molar mass. So our molar mass is 98 grams of the sulfuric acid. This one here contains 1 mole. And then what of the 19.6 grams of sulfuric acid? So this one here contains 1 times 19.6 over 98, and this one will be in moles. And what do we get? So 19.6 we divide by 98, it gives us 0.2 mole. We are not yet there. We have not yet got the molarity. We have only converted this mass here into moles, and this is the number of moles in 200 cubic centimeters. And since molarity is the number of moles in 1,000 cubic centimeters, let us convert this number of moles, which is only in 200 cubic centimeters, to the number of moles in 1,000 cubic centimeters. So we are looking for the number of moles in 1,000 cubic centimeters. So moles goes to the right hand side from first principles. And we shall say 200 cubic centimeters of the solution of sulfuric acid. How many moles of sulfuric acid are there? It contains 0.2 mole. And then what of 1,000 cubic centimeters of sulfuric acid? So this one contains, we cross multiply, it will be 0.2 times 1,000, and we divide by 2 100 mole. So let us look for the number of moles here. So it will be 0.2 times 1000, and we divide by 200. I have got exactly 1, and that is 1 capital M, which is the molarity of this solution. Remember that it can also be in moles per liter, or it can be in moles per cubic decimeters, and that is the number of moles in 1000 cubic centimeters, which is our molarity, and that is method number 1. Let us also look at method number 2. I'll give you both methods so that you get conversant with them, and so that it's very easy for you to pick either one of the two methods and you use the one which is seemingly simpler for you. So let us look at method 2. How to get the molarity of this same solution. Now in this second method, remember we are going to arrive at the same answer. In the second method, we are firstly going to convert this mass in 200 cubic centimeters of solution to the mass in 1000 cubic centimeters. We shall have achieved this. Then that mass we shall convert it to moles, and we shall have achieved this. That one gives us what we call the molarity of the solution. That is the number of moles in 1000 cubic centimeters. So let us firstly convert this mass in 200 cc to the mass in 1000 cc. We shall say 200 cubic centimeters of the solution of sulfuric acid contains 19.6 grams. And then what of 1000 cubic centimeters of the sulfuric acid? This one here contains 19.6 times 1000 over 200 grams. So what do we get from here? It will be 19.6. We multiply by 5 in this case. It gives us exactly 98 grams per liter. This is the concentration in grams per liter. Now, let us therefore change this mass here into moles. And if we are changing this mass into moles, we need to firstly work out the molar mass. So the molar mass of sulfuric acid, in this case it is 1 times 2. We are done with hydrogen, we go to sulfur, which is 32, and then we go to oxygen, which is 16 times 3. And this one will give us 2 plus 32 plus 48. So 48 plus 32 is 96, plus 2 is 98 grams. That's the molar mass of sulfuric acid. So if this is the mass of 1 mole, then what of the 98 grams, how many moles are there? So we shall have 98 grams of sulfuric acid contains 1 mole. And then what of this 98 grams? The 98 grams of sulfuric acid contains 1 times 98 over 98, and the unit remains mole. And what do we get from here? 98 divided by 98, we get 1, and the unit is capital M, or moles per liter, or moles per cubic decimeters. So you can see that in this method too, we firstly converted this mass here in 200 cubic centimeters to the mass in 1000 cubic centimeters. Then we got the number of moles in it. So this one gives us the molarity. Now, I would ask you to try this one here at your own free time. Something small here for you. I want you to do this simple exercise for yourself. Exercise. determine the molarity of each of the following solutions. Determine the molarity of each of the following solutions. Try this. We have got 5.6 grams of potassium hydroxide in 500 cubic centimeters of the solution of potassium hydroxide. Given that potassium is equal to 39, oxygen is equal to 16, and hydrogen equals to 1. Let's also try this one here. I'm going to give you 3.65 grams of hydrogen chloride in 150 cubic centimeters of the solution of hydrogen chloride, which is hydrochloric acid anyway, given that hydrogen is 1 and then chlorine is 35.5. Then the last one is let us use calcium chloride. For calcium chloride, let us use 5.55 grams of calcium chloride in 400 cubic centimeters of solution. Given that the relative atomic mass of calcium is 40, then for chlorine it is 35.5. Try this as part of your exercise so that you get conversant with this calculation. This is Tech Talks Education. Thank you for watching.